students, let us discuss about the special applications of our dot product. As we have discussed earlier, the angle between two diagonals of a cube. Meanwhile, the angle between a diagonal of a cube and the diagonal of a face of a cube, we found out. One is theta is equal to cos inverse of 1 by 3. Other one is theta is equal to cos inverse of square root of 2 by 3. Let us discuss the another application on the concept of dot product. What is that? Let us find out the angle between a diagonal of a cube and the edge of it. Let us see. The application is the angle between the diagonal of a cube and edge is dash. Yes, as you know already, right. So if I take this one as OA, this is represented with what I, this is what OB, this is represented with dot J, this is OC with what K. If I take this as O, this is D, OD is a diagonal of this, and OF is a diagonal of this, OC is a diagonal of a cube, and this is A. A is also diagonal of a cube. Now, this is this side DZ, BE and AF are parallel to OC. So therefore, equal and like vectors, these two are parallel and equal. These two are parallel. Okay. So let us see. So the proof of this one is, in a cube, OA bar is equal to I, OB bar is equal to J, OC bar be the edges. Next, OZ bar, or else first you find out OD bar. What is OD bar? OD bar is a diagonal of this face. I can write by using vector addition OA bar plus AD bar. OA bar is nothing but I. AD bar is parallel to OB bar. You take OB bar. It's I plus J. Meanwhile, I go to OZ bar. What is OZ bar? OZ bar is equal to OA plus AZ bar. How you wrote, sir? By using vector addition. So therefore, OA bar is equal to I. AZ bar is nothing but AD bar plus DZ bar. I can write OZ bar as I plus, what is AD bar? AD bar is same as OB bar and DZ bar is same as OC bar. In turn, I can write OZ bar as what? I plus J plus K. Now, this is enough for us. This is one diagonal and one edge. I take it as OB bar. It's very easy for in a pictorial representation. So therefore, so easily you can convince of this geometrical approach. So therefore, what is our context? Our context is in a cube, the angle between the diagonal and the edge. The diagonal and a edge. So therefore, this is the diagonal of a cube. You can also find out what that is A bar also. Not necessary. Already you know one edge, you know what one diagonal. So therefore, OB bar is equal to J is one edge of a cube. Then let theta be an angle between the diagonal OZ bar and edge OB bar, which implies OZ bar comma OB bar is equal to theta. I take it. So therefore, cos theta is equal to, by using dot product, OZ bar dot OB bar by modulus of OZ into that is modulus of OB. What is OZ bar? I plus j plus k dot j bar by modulus of OZ bar. It's a root 3. It's a what? 1. Now you take the dot product. I dot j 0. I j dot j. It's a 1. It's a what? J dot k 0. So therefore root 3. Therefore 1 by root 3. So therefore now theta is equal to cos inverse of 1 by root 3 is the what? Angle between the diagonal of a cube, and an edge. Similarly, in the same fashion, you can also find out the angle between the what? The diagonal OZ bar and OC bar, and OZ bar and OA bar, because OA bar, OB bar, OC bar are the edges. Henceforth, the angle between, instead of taking OZ bar, you can also go for what? AE bar. That is also a what? The diagonal of a what? Cube. Diagonal of a cube. Hence, the angle between the diagonal of a cube and the edge of it means what? Cube, is always, that is theta is equal to cos inverse of 1 by root 3. Cos inverse of 1 by root 3. Students, let us discuss the another important application of dot product on a cube. It comes under geometrical approach. What is that? It is very, very important from the competitive examination. What is that is? The perpendicular distance from of a corner of a cube from a diagonal not passing through it. Now look here. What is the what? Question or a concept oriented application? The perpendicular distance of a corner or distance of corner of a cube from a diagonal not passing through it. Meaning of this is that diagonal is not passing through that corner. From where? You are finding the what? The perpendicular distance to that diagonal. So therefore, let us see how to find out the perpendicular distance from a corner of a cube to a diagonal which is not passing through it. Now students, let us see. In this cube, now OX, OY, OZ are the axis. On the axis, OA bar, OB bar, OC bar are the edges of a unit cube. What is the unit cube? Because length of the edge or length of the side is what? 1 unit. Okay, it is perception left to the student. So therefore, now this origin, I take this is what? Therefore, I take this point as 1, 0, 0. Now, on y-axis, OB is a one edge. I take it is what? 0, 1, 0. Followed? 0, 1, 0. Next, this is K. Now this is nothing but, now K. So I can write this one as C. This C as 0, 0, 1. Length of this side is 1. This also 1. This also 1. So therefore, by definition, already you know it, P is a point in the space. Therefore, OP bar is nothing but I plus J plus K. Means what? Coordinates of P is what? 1, 1, 1. Followed? Now, this is the diagonal of a cube. For this diagonal, I am supposed to find out. You can take, instead of unit cube, you can also take A units also. Okay, if I take 1, you feel comfortable. You feel it's ease. So therefore, from this, I am supposed to find out the perpendicular distance. This is the perpendicular distance, CM. We are supposed to find out from the corner C to the diagonal OP, which is not passing through it. Followed? So therefore, now this is a C. From that we have to find out the perpendicular distance. Let us start. We completed the what figure. Now the proof of this one is very simple. Let OA bar, OB bar, OC bar be the edges of a unit cube along the OX bar, OY bar, Z bar respectively. So therefore, I told unit cube, which implies OA bar is equal to I, OB bar is equal to J, OC bar is equal to K. These are the directions along OA, OB, OC. They are measured along the what? X, Y and Z axis respectively. So therefore, now which implies OA, OB, OC is equal to 1 unit. When OA bar, OB bar, OC bar is equal to what? Unit length, then position vector of a point P is equal to 1, 1, 1. Since P is a point in the space, which implies OP bar is equal to I plus J plus K, where O is the origin. Where O is the origin. Yes, we have framed out edges as well as the diagonal. So let us find out the perpendicular distance from C to this diagonal. Now OM is the length on OP. This OM is length is nothing but a projection. Projection of what? Already we have dealt on this concept in the previous classes. Length is nothing but the projection, length OM is nothing but projection of OC bar along OP bar. Let us see. So therefore now what I write is, I can write this one as, I can write OM is equal to projection of OC bar on OP bar. This is given to be OC bar dot OP bar by modulus of OP bar. Modulus of OP bar. This is nothing but OC bar is nothing but a K bar dot of I plus J plus K whole divided by root 3. K dot I 0, K dot J 0, K dot K 1, 0 plus 1 by root 3. This is nothing but 1 by root 3. Right? So therefore, we have got OM is equal to 1 by root 3. Now I want to find out CM. What is CM? Let us this write IA is equal to 1, 0, 0, this point. So what is CM? From this triangle, from figure, OC square is equal to CM square plus OM square. OC square is nothing but 1. Why? K whole square 1. CM square, we are supposed to find out. OM I have found out already, it's 1 by root 3. 1 by root 3 whole square. Therefore 1 is equal to CM square plus 1 by 3. Now you transfer CM square is equal to 1 minus 1 by 3. Now CM square is equal to 2 by 3. Therefore CM is equal to square root of 2 by 3. Remember, it's a concept oriented application of dot product. The perpendicular distance of a corner of a cube from a diagonal which is not passing through 8 is what? Square root of 2 by 3. Is nothing but square root of 2 by 3. Yes, we come across now few applications which are similarity with what? Variety. The very first one is, in a cube, the angle between the two diagonals, theta is equal to cos inverse of 1 by 3. Angle between a diagonal and a what? Face diagonal is what? Cos inverse of 2 by 3, square root of 2 by 3. Angle between a diagonal and a edge is what? Cos inverse of what? Come on, 1 by root 3. Correct or not? Next, the perpendicular distance of a corner of a cube from a diagonal which is not passing through it is what? CM is equal to square root of 2 by 3. The another one is, important application is there in the dot product. Students, the another application of dot product is a unit vector parallel to parallel to xy plane and perpendicular to the vector a1i plus a2j a3k is dash. Okay, the unit vector parallel to xy plane and perpendicular to what? a1i plus a2j plus a3k. Let us see. If I take this is xy plane, I take this a vector. The vector which is parallel to xy plane, let us say r bar is equal to xi plus yj. Sir, why you have taken r bar is equal to xi plus yj? Because of the region, it is strictly defined in xy plane. Defined in xy plane. Z coordinate is equal to what? 0. Quite similar. In the same fashion, parallel to yz plane, r bar is equal to yj plus zk. Next, parallel to zx plane, r bar is equal to xi plus zk. Later, all these applications we shall discuss after this. First, let us concentrate, let us focus our attention only for what? xy plane. Now I start. This is x-axis, origin and y-axis. Let us see. The proof of this one is very simple. Let r bar is equal to xi plus yj be the vector parallel to the xy plane. Parallel to the xy plane. Given r bar is a perpendicular to the vector a bar is equal to a1i plus a2j plus a3k. He has not given a bar. I considered. Now perpendicular means it's a perpendicular. So therefore, now perpendicular means which implies when any two vectors are said to be perpendicular, r bar dot a bar is equal to 0. R bar dot a bar is equal to 0. When r bar dot a bar is equal to 0, r bar dot a bar is equal to 0. Now let us say xi plus yj dot of a1i plus a2j a3k is equal to 0. a3k is equal to 0. So therefore, take the dot product. I dot I is equal to 1. I dot j 0. I dot k. Or else a bar dot b bar when theta is not given. a1 b1 plus a2 b2 plus a3 b3. When a bar is equal to a1i plus a2j plus a3k, b bar is equal to b1i plus b2j plus b3k. Followed? So therefore, now what I do is, now this dot product is equal to 0. Take xa1 plus ya2 is equal to 0. xa1 plus ya2 is equal to 0, which implies y is equal to minus a1 by a2 into x. I have expressed y in terms of x. take this one, you substitute in this vector. Then substitute, put y is equal to minus a1 by a2 into x in r bar is equal to xi plus yj. Why? That is the vector which contains two scalar components x and y. Nevertheless, they are unknowns. What they are? Unknowns. So therefore, I can write r bar is equal to, yes, now you substitute xi minus a1 by a2 into z. Now that is into x. Now r bar is equal to, I can write, okay, now coming this one is xi minus a1 by a2 into what? xj. Now I want the unit vector. What is the unit vector? Unit vector parallel to xy plane. Parallel to xy plane is equal to r bar by modulus of r bar. You can take them as either plus or minus. Okay, so therefore plus or minus, I can write this one as xi minus a1 by a2, or else you can also take this cross multiply x into z by square root of x square plus a1 square plus a2 square into x square. Followed? Now you take x outside. So therefore, x into a2y a1j by a2 into, that is x is taken outside, x into a2 square a1 square. This a2 square comes to what? Numerator. This and this get cancels, x and get cancels. So therefore I can write a2i minus a1j by what? That is a1 square plus a2 square. I can write the unit vector parallel to xy plane is given by plus or minus a2 into I a1 into j by a1 square plus a2 square. a1 square plus a2 square. You can very well observe what are the scalar components are there. They will be there in the denominator under the square root. We have a2 and a1, correct or not? a2 and a1. Therefore, this is the unit vector parallel to what? xy plane is given by plus or minus a2 into y minus a1 into z by square root of a1 square plus what? a2 square. So therefore, the context is, this is the what? A vector parallel to xy plane and perpendicular to what? A bar. So in the same fashion, he may ask you to find out the vector parallel to yz plane perpendicular to a bar, parallel to zx plane perpendicular to what? A bar. If it is parallel to yz plane, same context, parallel to yz plane, remember parallel to yz plane, then you have to change. Instead of x and y, you have to go for what? Y and z axis. Y and z axis. You have to go like this. This is x, this is y, it's a z. You have to take here. This is r bar is equal to yj plus zk. This is a vector parallel to yz plane. Parallel to yz plane. In the same fashion, I can also go for what? So zx plane, if I go to zx plane, I can write this one as r bar is equal to s common xi plus zk. This is the vector. What is this vector? Roughly I am writing r bar is equal to xi plus yj. This vector is parallel to xy plane, parallel to yz plane, parallel to what? Zx plane. Parallel to zx plane. Yes, in the same fashion, what I proved here for this, you can also prove for what? R bar is equal to, that is yj plus zk be the vector parallel to yz plane. Given r bar is what? Perpendicular to the vector a bar a1i plus a2j plus a3k. R bar dot a bar is equal to 0. Instead of xi plus yj, you have to write yj plus zk. Now dot product is equal to what? 0. Therefore, instead of this y into a2, z into a3, you'll get what? Y and z. Take that y and z, you substitute in what? R bar. Find out a unit vector. Similar to what? Parallel to what? Zx plane. Instead of this, look here, instead of this r bar, let us consider what is that? R bar is equal to xi plus what? Zk is the vector parallel to what? Zx plane. So therefore, now I take xi plus zk be the vector parallel to the y, that is zx plane. Instead of y, you have to take it as what? Zx plane. So therefore, given r bar is perpendicular to a bar, r bar dot a bar is equal to 0. Therefore, xi plus zk dot this one is, then you get what? xa1 plus za3 is equal to 0. Therefore, z is equal to something. Next, you substitute in what? R bar. Find out a what? Unit vector. No need to prove separately. Then you tell me what are those unit vectors. Let us analyze. Without proving in this way, it's a what? Laborious. It's a time waste. Instead of this, on this fashion only, let us think about cyclic order. A, B, C, B, C, A, C, A, B. Followed? A, B, C, B, C, A, C, A, B. Now, let us discuss. Now, the unit vector parallel to xy plane and perpendicular to what? Vector a1i plus a2j plus a3k. First one is parallel to xy plane. Parallel to xy plane. When it is parallel to xy plane, first one is plus or minus a2 into I, a1 into j by square root of a1 square plus a2 square. This is second one is, this is parallel. So therefore, this is parallel. Next, parallel to yz plane, okay, and perpendicular to a bar, parallel to yz plane and perpendicular to a bar is plus or minus. The third one is parallel to zx plane and perpendicular to a bar is plus or minus. Right. I told in the cyclic order we can change. In yz plane, z component and y component will be there. You go in a cyclic order. A1, that is A1, A2, A3. Next A2, A3. After A2 what comes? A3 comes. After I what comes? J comes. After what? A1 what comes? A2. After j what comes? K. Whatever the scalar components are, same thing you write. A2 square plus A3 square. This is the unit vector parallel to YZ plane and perpendicular to what? A bar. Perpendicular to A bar. Next I go to this one is, that is the unit vector parallel to what? ZX plane, perpendicular to what? A bar. Yes, once again in cyclic order, in ZX plane only X component and Z component will be present. So therefore, think about them in a cyclic order. Okay, now after A3, what comes? A1, after J, what comes? K, after A2, A3 comes, after K, I comes, by square root of what? A1 square plus A3 square. Remember students, the unit vector parallel to what? XY plane and perpendicular to what? A bar is what? Plus or minus A2i minus A1j by square root of A1 square plus A2 square. The unit vector parallel to what? YZ plane and perpendicular to A bar is, come on, change in the what? Come on, cyclic order. A3j minus A2k by square root of what? A2 square plus A3 square. The that is unit vector parallel to ZX plane and perpendicular to A bar is plus or minus. Cyclic order you interchange A1k minus A3i by what? Square root of A1 square plus A3 square. This is the concept of what? Dot product towards the what? The unit vector parallel to what? Coordinate planes and perpendicular to what? One vector. Followed? Cross vector product. Students, let us discuss about the vector or a cross product of two vectors. Earlier in the scalar product, we have taken between the two vectors as A bar dot B bar, but now we are defining as A bar cross B bar. This can be read as A bar cross B bar or else vector product of A bar and B bar. Remember, the scalar product of two vectors is a scalar quantity, but the vector product of two vectors is a vector quantity. This has much more applications in physics in finding the vector perpendicular to the plane. First one. The second one, finding the perpendicular distance from a line to the plane. Third one is finding the what? Vector area of the what? Curve bounded by the region, and etc. So therefore, first one is, it is vector product. Second one gives what? Come on, finding the perpendicular distance or else from the what? Line to the plane. Next one is finding the what? Vector perpendicular plane containing A bar and B bar. Last one is vector area of a curve of the region bounded by it. Still we have many applications, momentum, etc., etc. in physics you find. So therefore, vector product is a vector quantity. Let us discuss about what is vector product. Vector product or a cross product of, let us consider the two vectors A bar and B bar, which are non-zero and non-parallel vectors. Let us start. So the definition of this one is, definition, let A bar comma B bar be two non-zero non-parallel vectors. Non-parallel vectors, and theta is the Theta is the angle between A bar comma B bar. Then vector or cross product of A bar and B bar is defined as A bar cross B bar. A bar cross B bar. First one, if it is a vector is a physical quantity which is having both the magnitude and a direction. What about its magnitude? What about its direction? Let us see. Whose magnitude is the product of three positive real numbers that is mod A mod B into sin theta. Now mod A bar is a positive quantity. Mod B bar is also positive quantity. Sin theta also is what common? Positive quantities. Whose magnitude is the product of three positive real numbers. What about its direction? Now I go for whose direction is along the unit vector n cap, which is perpendicular to the plane, generated by A bar comma B bar, and the vectors A bar, B bar, n cap forms a right-handed system. Forms a what? A right-handed system. Let us see how it is. Look here. If I take this is A bar, this is B bar, theta is the angle between them, this is nothing but n cap. It's a right-handed screw, right? It is just like this, right-handed screw. Okay, if I show like this, it would be better, right-handed screw. So it will be like this. So therefore, when you rotate A towards B, when you rotate A towards B, towards n cap, they are in right-handed system. So when you rotate A towards B, A cross B is generated along n cap. It means that, so therefore, it means that A cross B will be along the n cap. Nevertheless, A cross B and n cap are collinear. We know that very well. When any two vectors are said to be collinear, one vector can be expressed as scalar multiple of another vector. Therefore, what's the direction? I can write here A bar cross B bar is equal to mod A mod B into sine theta into n cap. Am I correct? Why? Scalar multiplication of a vector is once again a vector quantity. This is vector. When RHS is vector, it is quite obvious. LHS must be a vector. Therefore, A bar cross B bar is equal to mod A mod B sine theta into what? N cap. This is the direction. So therefore, hereafter, so A bar cross B bar is equal to mod A mod B sine theta into what? N cap. This is in what right-handed system? A cross B is generated along what? N cap. A cross B is generated along n cap. Followed? So I can also go for the another application is, if I go to this one is like this. This is O, this is what? Come on, B bar, this is what? A bar, this is the vector minus n cap, like this, theta. So therefore, it will be like this. Therefore, I can write B bar cross A bar. When you rotate B towards A, B cross A is generated along what? This minus n cap. When compared to n cap, this is n cap, this is minus n cap. N cap is in this direction, minus n cap is in what? In this direction. Both are opposite in direction. But maybe n cap, maybe n minus n cap, both vectors are perpendicular to the plane containing A bar and B bar. A bar and B bar. So therefore, now here I can write A bar, B bar, n cap are in right-handed system. Followed? So here B bar, A bar minus n cap is also in what? Right-handed system. Therefore, B cross A in this direction, A cross B in this direction. We can easily understand A cross B is not equal to B cross A. Then what it becomes? Opposite direction. A cross B is equal to minus B cross A. A cross B is equal to minus B cross A. Followed? So therefore, this is the concept of what? A cross B. A cross B is a vector which is perpendicular to the plane containing A bar and B bar. Okay. When A cross B is the vector perpendicular to the plane containing A bar and B bar, then how many vectors which are perpendicular to the plane containing A bar and B bar? Namely, there are two unit vectors. Only there are two unit vectors. How many vectors are perpendicular? They are infinite. How many vectors which are perpendicular to the plane containing A bar may be infinite? Among them, A cross B is a one vector. Then how many unit vectors are perpendicular to the plane containing A bar and B bar? Only two. One is n cap, other is what? Minus n cap. So therefore, hereafter, number of unit vectors which are perpendicular to the plane containing A bar and B bar are only two. One is n cap, other is what? Minus n cap. One is in positive direction, other is what? Negative direction. So therefore, from this figure, what we understood is A cross B is a vector which is perpendicular to the plane containing A bar and B bar. B cross A is also perpendicular to the plane containing A bar and B bar, but is in this direction, this is in opposite direction. So therefore, now you can very well observe A cross B is defined as aptly modulus of what? A cross B is equal to mod A into mod B into sin theta into what? N cap. Sin theta into N cap. And from this figure, we come across many applications. First one is A cross B is equal to mod A into mod B into sin theta into N cap. And the second one is A cross B is a vector which is perpendicular to the plane containing A bar and B bar. And A cross and the number of unit vectors which are perpendicular to the plane containing A bar and B bar are two. One is N cap, other is what? Minus N cap. And meanwhile, A cross B is always what? Parallel, collinear with what? N cap. Henceforth, I can write one vector can be expressed as scalar multiple of another vector. Another vector. Followed? This is about the definition of what? Cross product. Now look here. A bar cross B bar is equal to 0 or 0 bar, which implies 0 or 0 bar, which implies A bar is equal to 0 or B bar is equal to 0 or A bar is parallel to B bar. If it is A bar is parallel to B bar, theta is equal to what? 0 degrees. When theta is equal to 0, sin 0 is what? 0 degrees. Why? Because A bar cross B bar is always equal to 0. Why? A bar cross B bar is equal to mod A into mod B into sin theta into N cap. When theta is equal to 0, what is sin 0? 0. Therefore, A cross B is equal to 0. Sir, if A bar cross B bar is equal to mod A into mod B into sin theta and N cap, if A bar is equal to 0, it's a what? Null vector. Its magnitude is what? 0. 0 intrinsic is what? 0. If B bar is what? 0. B bar is equal to 0 means what? Null vector. So therefore, A cross B also becomes what? Null vector. Hereafter, whenever, wherever you come across A bar cross B bar is equal to 0, which implies A bar and B bar must be either 0 vectors or null vectors or collinear or parallel. And remember, meanwhile, modulus of A bar cross B bar is always less than mod A into mod B. Why, sir? If I take A bar cross B bar, mod A into mod B into sin theta into what? N cap. Take the modulus. Now look here, modulus of N cap becomes what? 1, and modulus of sin theta is always less than or equal to 1. So therefore I can write less than or equal to 1 or equal to this also, correct or not? This also scalar, this also scalar. Let us see the geometrical interpretation of cross product. Look here, this geometrical interpretations gives many concept oriented applications. We have discussed similarly geometrical interpretation of dot product as projection of A bar on B bar, projection of B bar on A bar, which was very important concept. Same Here also we come across what? Geometrical interpretation of cross product. Yes, geometrical interpretation of vector cross product, vector or cross product, vector or cross product. So let us see. O, A, C, B. This is one diagonal. This is a perpendicular to it. This is theta. Take this one as A bar. Take this one as B bar. The geometrical interpretation of vector or a what? Cross product can be interpreted as the area of a parallelogram, and as well as when you know the area of a parallelogram, you can also find out the area of a triangle. Area of a triangle. So therefore, area of a triangle with, for parallelogram, OABC with A bar and B bar as adjacent sides, and angle between them is what? Theta. Let us take the angle between A bar comma B bar is equal to theta. Is equal to theta. So therefore, I take let OA bar is equal to A bar, OC bar is equal to B bar, be the adjacent sides of a parallelogram draw CM perpendicular to OA and angle between A bar and B bar is theta. By definition of vector or cross product, A bar cross B bar is equal to mod A mod B sin theta into n cap. Sin theta into n cap. Followed. So therefore, now I can write, take the modulus on both sides. So therefore, modulus of A into modulus of B into sin theta into modulus of n cap. This is already positive numbers. No need to take what? Modulus. Since modulus of n cap is equal to 1, I can write A bar cross B bar is equal to mod A mod B into sin theta. We already know that by using properties of triangles, area of a triangle is equal to half into AB into sin C, or half into BC into sin A, or half into CA into sin B. B is the angle between what? A and C. C is the angle between what? A and B. Similarly, A is the angle between B and C. So therefore, now I can write this one as what? Come on, A. Now I can write modulus of A bar cross B bar is equal to F into modulus of A bar into sine theta. This implies A bar cross B bar is equal to 2 into area of triangle AOC. Area of a triangle AOC. Now you can very well observe. So therefore, area of triangle AOC is equal to half into modulus of A bar cross B bar. Means, which implies area of a triangle is equal to half into A bar cross B bar. Remember, when A bar and B bar are the what? Sides of a triangle, the area of a triangle is half into modulus of A cross B. Followed? If three sides are given, A bar, B bar, C bar, you can go for it. Either half into A cross B, or half into B cross C, or half into C cross A. All together they are same. So therefore, what I do, this area of a triangle, I want to find out the area of a parallelogram. Area of a parallelogram OABC is equal to 2 times of area of triangle AOC. Am I correct? Because parallelogram is a sum of true triangles. Parallelogram is sum of two triangles. So therefore, now twice the area of a triangle. Now I can write this one as this equal to twice into F into A bar cross B bar. 2 get cancels. Therefore, modulus of A bar cross B bar. What we have arrived at the conclusion is the geometrical interpretation of cross or vector product gives us to interpret as A bar and B bar are when they are adjacent sides of a what? Parallelogram. Then the area of a parallelogram is what? Modulus of A bar cross B bar when they are adjacent sides. Meanwhile, what is the area of a triangle with A bar and B bar as the sides is half into modulus of A bar cross B bar. This is how geometrically you can interpret the vector or a cross product as area of a triangle and what? Area of a what? Parallelogram. Sir, when A bar and B bar represent the adjacent sides of a what? Parallelogram, what about the area of a parallelogram with diagonals? With diagonals. So therefore, what I do is, let us see how to find out the area of a parallelogram with a side with the diagonals A bar and B bar. Now the area of a right, the area of a parallelogram with diagonals A bar and B bar is half into modulus of A bar cross B bar. Right, a modulus of of into A bar cross B bar. Let us see. If I take parallelogram, yes, A, B, C, D. This is one diagonal, another diagonal. They meet at a point P. Means they bisect each other. Acts as a midpoint. Acts as a midpoint. So therefore, if I take AC bar as A bar, BD bar as B bar, this C is given to be A bar by 2. This also A bar by 2. This is B bar by 2. This is what? B bar by 2. By drawing two diagonals, when they meet at a point P, we have arrived at forming four triangles. One, CPD, next DPA, next APB, next BPC. Right? So therefore, now here A bar by 2, this is B bar by 2. For this triangle, these are the two sides irrespective of the dimension. We never focused on the what? Dimensions, as we have proved in the earlier cases, as a geometrical interpretation of cross product. As A bar and B bar as the sides, the area of the triangle, we found out half into modulus of A bar cross B bar. Followed? So therefore, now here also A bar by 2, B bar by 2 as the sides. What I do is, the proof of this one is, in a parallelogram, ABCD, AC bar is equal to A bar, BD bar is equal to B bar, be two vectors. From figure, I can write AP bar is equal to A bar by 2, PC bar is also A bar by 2. BP bar is equal to B bar by 2, PD bar is equal to B bar by 2. Right? By 2. So therefore, I can write the area of parallelogram ABCD is equal to 4 times of area of triangle PCD or PAD or PAB or PBC. So therefore, what I can write is, this is equal to 4 into, what's area of a triangle? F into PC bar cross PD bar, two sides. But we have PC bar as A bar by 2, PD bar as what? Come on, B bar by 2. Substituting them, I can have 2 into PC bar, A bar by 2, this is B bar by 2. I can write 2 into A bar cross B bar by 4 get cancels, therefore F into modulus of A bar cross B bar. Remember the comparison between the area of the parallelogram with A bar and B bar as adjacent sides and impertinent the area of the parallelogram formed by the diagonals as A bar and B bar is always equal to area of a triangle. Area of the parallelogram with sides is just modulus of A bar cross B bar. What is area of a parallelogram with diagonals? Is equal to area of a what? A triangle formed by the what? Formed by A bar and B bar as a sides. So therefore, remember the students, the area of the parallelogram with the diagonals is equal to area of the triangle formed by the what? A bar and B bar as the sides. This is the what? Area with diagonals. Thank you.